Hello there, this is Mr. Frazier, and I am actually going to do problems 1 through 30 of the exam review, or we're going to start with problem 1. All right, and as you look at this, the exams are next week, Monday, Tuesday, Wednesday, Thursday, Friday. This is done for those of you who miss a day and or didn't have the materials the day we went over it. Okay, so please bear with me, and if I go too fast, you can always rewind it, re-listen, replay. Okay, problem 1 has to do with knowing what a counterexample is. Hopefully you know a counterexample is something that's given to prove the statement false. Starts with, if you live in Springfield, then you live in Illinois. And the problem isn't the if part of the statement, it's the then part. So the if part is the hypothesis, the then part is the conclusion. So we're looking for another Springfield. That's how we would prove a counterexample. So hopefully you know that there is another Springfield in Massachusetts. All right? Problem number 2. Knowing what a counterexample is. Okay. Problem number 2. How are these two angles related? One of them is 54 degrees. The other one is 126 degrees. Hopefully you understand that they are not connected. If they were connected, they would be called a linear pair, because they are adjacent and supplementary. But we just call these angles supplementary because they add up to equal 180 degrees. All right, problem number 3. Which angles are corresponding angles? That means hopefully you remember that corresponding angles are the ones that make the letter F. So those would be examples of corresponding angles. You have to know what same side interior, alternate interior, corresponding. You have to know what all those are. Hopefully you also know that these are called vertical angles. This one and this one. These are called corresponding. Ones that are right next to each other are called, yes, a linear pair. Okay. You have to know that all angles are congruent unless they add up to 180, and the only two that add up to 180 are the same side interior and linear pair. All the rest of them are congruent. That answers problem number 4. Problem number 5. Why are triangles congruent? Triangles are congruent by one of 4 ways, or 5 ways. You have angle, side, angle, side, 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 angle, side, and hypotenuse leg. In this case, this is the bow tie, and you know you're supposed to have vertical angles. So these two triangles will be congruent due to angle, side, angle. Correct. If the congruency mark was on this side over here, it would be hypotenuse leg. Okay. Problem 6. Again, one of the reasons we have the vertical angles, you're supposed to add the congruency marks. You know the picture you originally have doesn't have those. And then you use one of these 5 reasons. It would be angle, side, angle. Problem 7. This is a reflexive side. So hopefully you know you add congruency marks there because it's a reflexive side. What do you need? All right, problem number 8. Deals with, do you know what a parallelogram is? 4-sided shape. Do you know what a rectangle is? Hopefully you know a rectangle looks like this. My paper got a little wet. And a square looks like this. Alright, so we have parallelograms, quadrilaterals. These are all quadrilaterals. That is a parallelogram. This is a parallelogram, but it's also a rectangle. And this is a square, which is also a rectangle, which is also a parallelogram. These 3 are all related. This one is not. All right. Problem number 9. Problem number 9 was our umbrella rule. That's where we talked about whether or not things on the perpendicular bisector. So you got to make sure they're on the perpendicular bisector. Not the thing being bisected, but on the bisector. And any point on here is the same distance to J and K. So A is the same distance from A to J as it is from A to K. from B to J as it is from B to K. You have to be really careful. So anywhere I move a point on here, it's equal distance to J and K. That means the one with the congruency marks, those two line segments are equal distance, not the ones if I turn it sideways or cattywampus. So you got to be really careful that the perpendicular bisector is where the point has to be, and then they're equidistant to the other line segment. Problem 10, which one of these angles is the largest? That would be B, because it's across from 7. Which one of these is the smallest? It's A, because it's across from 5. And remember, you're supposed to be doing these questions on your own, and then I'm kind of reviewing and going over how or why you should have gotten them correct. If a triangle has these sides, is it really a triangle? Hopefully remember that you're supposed to do what with the two smallest numbers? Right, you add the two smallest numbers, and your answer must be bigger than the third. So this one, 11 and 8, is 19. 19 is not bigger than 19, so this could not be a triangle. If this was 20, then yes, 20 is bigger than 19, so it is a triangle. But 19 is not bigger. It can't be equal to, it's got to be bigger. Problem 12, if I give you two sides, you're supposed to add them and subtract them. So 15 and 3, which means you must be bigger than 3, but smaller than 15. Problem 13 is on a graph, and anything that's on a graph, you'll have to use one of the formulas. So chances are you're either using midpoint or distance, and in this case, we're using distance formula. Now, do you have to use the distance formula for all the sides? Yes, you have to use the distance formula for all the sides that aren't horizontal and vertical. Otherwise, if they're horizontal and vertical, you can count, okay? But anything that's not horizontal or vertical, you'd have to find the distance formula. This one happens to be the distance formula from ocean view to seaside. And then you have to be really careful with that answer, because every unit on that picture is representing 5 miles. So when you finish, you not only have the distance in units, but then you have to multiply by 5 to actually find the real mileage. Number 14 is a picture. So you'd have to be able to follow along with the picture. And the picture asks us, which one of those is reflected over the x-axis? Hopefully you know reflection means it has to go across the x-axis. So there's only one of those that goes across the x. One goes across the y, and if you lose track, just look for the little x and the little y. Problem 15. Problem 15 is a proportion problem. And if you set up the original proportion, which this is the original proportion, 4 over 8 is equal to 12 over 24, the matching sides. And when you cross multiply, you would get certain answers. And what they want you to do is which answer gives you the same result if you cross multiply. So I'm looking for a 4 across from a 24. So when I look through the answers, there's only one where the 4 is across from 24. This proportion would give me the same answer as my original proportion. Problem 16. Again, it's asking for the midpoint, except for this midpoint formula, there's no x and y, it's just the x coordinate on the number line. Number 17. Midpoint formula again? Yes. So they give you 2 points, you find the midpoint. You add the 2 x's, divide by 2, add the 2 y's, divide by 2, and your answer is 7, 6. For problem 18, they give you the midpoint, which is the answer to these problems. So the variable is now in the problem. It's x plus 8, which was the endpoint, divided by 2 equals 8. And x and y plus 20 divided by 2, because the 20 was given to you in the problem, equals 15. 8 and 15 are the actual midpoint answers. And then you have to do all your algebra backwards. You multiply by 2 first, you get y plus 20 equals 30, so y equals 10. And the other one up here, you get x plus 8 equals 16, so x equals 8. So your other endpoint would be 8, 10. Right, so far so good. Number 19. Number 19, you're going to want to draw out a picture. It starts with a rectangle. So you draw that rectangle out, and it's 33 by 39. And then it says you want to put a 3-foot walkway all the way around it, which means it's not just 3 feet bigger in each direction. It's now a total of 6 feet bigger, because you have 3 feet on this side and 3 feet on this side. So 3 plus 39 plus 3 is 45. And then you have to do the same thing going up and down. This would be 3 plus 33 plus another 3, which is 39. Now that's only part of the problem because they asked for the perimeter, which would be 39 plus 45 plus 39 plus 45. 20 is another perimeter problem, except it's on a graph, so you're going to use the distance formula. 21, they said it's a square, and they said it was 72 was the perimeter, so hopefully you know you take square with all equal sides, you divide it by 72, or 72 divided by 4, and you get 18. Problem 22, you have to make sure to change your 2 yards to feet. So you have 6 feet by 5 feet. That'll help you get the area correct. Problem 23, you have a square and a circle. So you have to do the area formula for a square and a circle. Once you find the area for the square and the circle, when you have 2 things inside of each other, you subtract them. If you're sitting next, 2 things are next to each other, you would add them. So this is 14 times 14 minus pi r squared. Put in the numbers, put it into your calculator, it gives you an answer. Same thing with 24. The 24 is the area of the big square, which is 64. The area of the small square, which is 4. So all the areas together are 68. 25. Translations. Where we're moving. Left and right adds or subtracts to x. Up or down adds or subtracts to y. So you're basically counting. Where did it move? What did it move? This one said you're moving left 3 and up 7. So it'd be x minus 3, y plus 7. Okay, the 26 is done the same way. When you're moving left, you subtract. When you're moving right, you add. When you're moving up, you add. When you're moving down, you subtract. So all of these have a tendency of looking similar, but again, different work. All right, 27 and 28. 27 was a picture one where you had to do a slide, so you had to pick a point to count from. Hopefully you understand that you're looking at your picture. And I would tell you to use point C, because point C is at the corner. It's at an actual unit. It's at 1, -1. And then you would count to C prime. All of the points will move the same. So you just got to do it for 1 point, from A to A prime, or B to B prime, or C to C prime, or D to D prime. It doesn't matter which one you pick, as long as you pick one. Like I said, I chose C because it's on the corner. So I move 3 to the right, which would be x plus 3, and 1 up, which would be y plus 1. 28. 28 is the degree of rotation. Hopefully you understand that with a degree of rotation, you're talking about taking the number 360 and dividing it by the number of pieces. And in this case, it's 10. Okay? And then we have to count from I to G. That tells me how many pieces I get. So we know it's 36 degrees each piece. And when I count from I to G, hopefully you know you counted 2 pieces. You start at I, that's not 1. When you move to H, that's 1. When you move to G, that's 2. So that's a 72-degree rotation. And when you rotate, you must always rotate counterclockwise, unless they tell you to rotate clockwise. 29 just asks you if it's a scale factor. Hopefully you know that a scale factor is got to be in the same units. So I changed the model of the tower from inches to feet, which makes 2 feet. That's how I got 2 feet. You always got to change the units, must be the same. And then it says from the model to the actual height. So you do the model first, then the actual height. You got a nice calculator, put it in there, you'll get 1/725. Problem 31. Already done. All right, thank you very much. We'll continue with 31 tomorrow. Alright, so here we go, the review for the rest of the geometry assignment. We look at problem number 31. And problem number 31 says that you have red and gray bricks. They're used to decorate the wall. It says the number of red bricks to red bricks is 5 to 2. When you're dealing with proportions, you have to pay attention to the words. Okay. This is where many of you are going to have a problem because the next number they give you is 175 total bricks. Now the problem is you can't set up a proportion using these two numbers because this is the number of red bricks and this is the number of gray bricks. You need the number of total bricks. Hopefully you understand the number of total bricks would be 7. Okay, you'd add the 5 and 2 and get 7. Now you can write a proportion because the words match. You have total and total. And then the numbers on top will match. And they want to know how many red bricks you'll have. So that means that you need red, and then this would be the number of red bricks. You would then cross multiply and get your answer. All right, problem 32. Again, dealing with proportions and ratios. The idea of this one is they give you the word complementary. Hopefully you understand that complementary means, correct, two things that add up to equal 90 degrees. They give you the ratio of 1 to 4. Now they haven't given you any of the numbers, so you're supposed to make this 1x plus 4x equals 90. You would solve that and get an answer for x. Now again, the question asks you what are the measure of the angles. So that means just finding x isn't going to be good enough. You need to find x and then turn around and do what with it? You need to plug it back in. Okay? When you plug it back in, you'll get the answer for both of your angles. Remember, this is one angle, this is the other angle. Hopefully you know that your answers, your numbers, should also add up to equal 90 degrees. Problem 33. Problem 33 revolves around the fact of knowing what a triangle is. Triangle adds up to, correct, 180. And they gave you the ratio of 3 to 5 to 7. Okay? And you would add those up to equal 180. And again, this is just the arithmetic part. The question asks you, what is the measure of the smallest angle? So that means after you get an answer for x, you'd have to turn around and plug it back in to your problem to get an answer for the problem. All right, 34 has to do with proportion work, finding matching sides. Hopefully you know that 2 matches with 8. So 2.5 matches with x minus 3. Okay, and you're picking numbers that are from matching parts of the polygon. You can pick 4 and 16. Doesn't matter which 2 you pick as long as you use the matching ones that you need. Then you cross multiply. The key to this one is making sure that when you cross multiply you remember to distribute. This becomes 2x minus 6. Okay? And then equals whatever the cross multiplying is, and then solving and finding the value of x. Okay, looking at problem 35. Problem 35. Again, it has 2 triangles. You write a proportion. They're similar, so you find things that, correct, match. So this would be 5x over 5, because those match, and equals 4 over x. Okay, and I will actually do this math problem simply because most of you are not remembering how to multiply 5x and x. 5x and x is 5x squared, and then 5 times 4 is 20. And then to solve this problem, you have to do everything backwards. So normally you would do exponents first and then multiply. So when we do everything backwards, we divide first, then square root. So you divide both sides by 5, and you get x squared equals 4. And when you square root, you get x equals 2. Okay. One of the harder problems, but you do have to remember how to square and square root, how to go forwards and backwards. Problem 36. Problem 36 asks, are the 2 triangles similar? What are the 3 ways in which we prove triangles are similar? Remember, the angles are congruent, so we can use the angle-angle theorem. We can use the side-angle-side theorem, or the side-side-side similarity theorem. Now remember, there's similarities and there's congruencies. For the similarity theorem, it's important that you understand that the sides must be proportional, which means you have to prove that the sides that are corresponding or matching are similar. Okay, and we prove that they're similar by doing proportion work. Now in this case, 36, it's just angle, angle. Now you have to be really careful because most of the pictures, they only give you 2 of the 3 angles. Hopefully you understand how many degrees are inside of a triangle, and you have to find the missing angle first before you can use any of these. All right? Same thing with 37. Hopefully you know that one is also angle, angle. You should recognize the bow tie and the vertical angles in problem 37. 37 has a bow tie and vertical angles. 38, it asks, are these triangles similar? And if so, write a similarity statement, which means you have to match up the stuff. So we would do 5 over 7.5 equals 8 over 12. Now remember, I told you can just list them in order from least to greatest and they'll match up naturally. So what is 8 times 7.5? Correct, it's 60. What is 5 times 12? It's also 60. Okay. So are those triangles similar? Yes. Due to what reason? They'd be similar due to side, side, side similarity. And then I'd write the similarity statement. So that would be triangle ABC is similar to triangle MNO. Okay. And that is 38. I apologize, not 37. 39. 39 is using the side splitter rule or the similarity rule. It's again asking you, are these triangles similar? You should know that you do have a reflexive angle. That's where you have one triangle inside the other triangle and they share the same angle, which happens to be this angle. That angle is reflexive in both of them. So to keep it straight, you just redraw the 2 triangles, making sure the smaller one has the sides of, correct, 3 and 30. But then you have to be careful with the bigger one because the bigger one has the side of 40 and 4. And how did I get 40? Hopefully you know that this is 30 and this is 10. Whenever we have things that are next to each other, we're supposed to add them to find the whole length. Okay, and then you would cross multiply. You do 3 over 4 is equal to 30 over 40. And of course you should see that they are proportional just because you can make 3/4 is equal to 3/4. So they'd be similar due to side, angle, side. You can only use side, side, side similarity when you have 3 measurements on all 3 sides. Otherwise, you cannot use side, side, side similarity. All right, problem number 40. You'll see that you have 2 triangles that are similar, and they asked what are the reasons why they're similar. And that you're going to have to use, hopefully you use side, angle, side by writing the proportion, which would be 8 over 16 is equal to 32 over 64. You'd cross multiply, and you would see that these are not similar. Why? Because 8 times 60 is 480, and 16 times 32 is 512. So these 2 triangles are not similar. Even though there's an angle measurement that's the same, the sides are not proportional. So they are not similar. 41. They want you to use the sides that are proportional. So when you look at 41, again, you have the 2 triangles. It's easier just to redraw the 2 triangles. Now you can also use the side splitter rule only if it was dealing with the sides. This one's not dealing just with the sides. In other words, here's your regular triangle, and here's your other triangle. You have 14 and 7 and 28. Okay, and this would be 2 different triangles. Side splitter rule only works if you're going down the sides. Okay, we're not going down the sides this one. We're using small triangle, big triangle. So here's the sides for my small triangle, 14 and 28. Here are the sides for my big triangle, 21 and x. Notice 14 is next to 7. When we have 2 things next to each other, you add them. All right, so it would be 14 over 21 because these are matching equals 28 over x, and then you would cross multiply and solve for x. Now, that's if they were similar. Now, in this case, they're not similar. Why? Because they don't give you enough information to prove that those two triangles are similar. They give you 2.5 sides. You need a total of 4. Okay. Right, problem 42. That is called a what? The tree in that picture is called a what? Correct. It is a mid-segment. So we're now getting into the stuff that deals with chapter 5. And mid-segments, okay, are always half of the third side. So if the building is 160 feet tall, and the reason I know it's a mid-segment is because it's connected by 2 midpoints. Those congruency marks are the things that should be attracting your attention every time you're doing a problem. If you're not paying attention to the congruency marks, or you think they mean absolutely nothing, that's where you're going to have an issue. This is a mid-segment because these are called midpoints. How do I know they're midpoints? Because they're cutting the line segment into 2 equal pieces. So if this is 160, that means this is 80. All right, 43. Again, a proportion problem. Now, they've given you this as a proportion. You can do it as a proportion problem, or you can do it as a mid-segment problem. No one really cares which way you do it. They're both going to give you the same answer. The next one is a proportion problem. It has a flag and a person, and then it has that the angle measurements are the same, and then it gives you that there's 12 feet and 48 feet. And they want to know how tall the flag is. Now, here's the problem. When you find your answer, you're going to have to do what? Well, let's get there first. So you would have 5 is to x as 12 is to 48. And why do you have to match them up like that? Because you have to match corresponding sides. Now, if you want, you can write 12 is to 48 or 48 is to 12. It doesn't matter which way you go. But the key to this is on the flag, this is on the flag, this is on the person, this is on the person. So if you match up the words, you put the numbers in the right spot. As long as the person is matched with the person and the flag is matched with the flag, you're good. And you cross multiply and solve, and you get the answer for the flag. Okay. All right, so we move on to problem 44. 44 is a geometric mean problem. Hopefully you remember that arithmetic means you added up all the numbers you had and divided by the total numbers that were there. Geometric mean is you multiply and then square root. So you can do geometric mean problems the same way all the time. Okay. So you'd multiply those two, cross multiply, you get x squared equals 60, and then to solve for x, you'd have to square root. Okay. It's always the same thing. Cross multiply, square root, cross multiply, square root. 45 deals with you being able to split it into several different triangles. Remember, we have our small triangle, we have our medium triangle, and then we have our large triangle, and there's some sides that always match up. Right? So the first side I always do is the hypotenuse because it's the easiest to identify. So in B, the hypotenuse of the small one is B. The hypotenuse of the medium one is 10, and the hypotenuse of the big one would be 8 plus A, right, because when they're next to each other, you add them. The third side, or the shortest side, is A, and we know that whatever the hypotenuse is of the small one, it's the shortest side of the big one. They match. And the hypotenuse of the medium one is always the long side. So these two numbers are always the same, and this number are always the same. Which gives me only one number left to put on my picture, and that's 6. Okay. So 6 goes there, 6 goes there. Hopefully you know you have all sides of the medium one, 6, 8, 10. And now you're just matching up the other one. So if I want to find B, I can do triangle A, 6 is to 8, those are the matching sides, equals B is to B, right? Oh, I'm sorry. 6 is to 8 as B is to 10. Okay, cross multiply and solve. And then you can do the same thing for A. All right, 46. All right, so we're continuing with problem number 46. 46 is the same as 45. You start by redrawing the triangles. Okay, so you have a small triangle, you have a medium triangle, and you have a large triangle. And again, you should know that the hypotenuse of the smaller triangle is this side of the bigger one. The hypotenuse of the medium is this side of the larger one. Okay. So the hypotenuse of the small one is the letter B, so B goes here. The hypotenuse of the medium one's not given, so I don't have this side. I do have the hypotenuse of the whole side because 32 and 2 makes 34. Anytime you have numbers next to each other, you add them. The small side is 2. And then we have the piece in the middle, which is A. And the piece in the middle is A here and A here. Remember, these repeat in every picture. Whatever is on this side is always here. Whatever is on the hypotenuse is always here. Whatever is on this hypotenuse is always here. It's memorization. And then you're going to find or match up the pieces you need. So you can use the small triangle and the big triangle to find B, because B matches with 34, so B over 34. And 2 matches with B, 2 and B. This is an example of a geometric mean problem. So you cross multiply, you get B squared equals 68. And the square root of 68 is 2 square root of 17. Remember, this is why you have that calculator, so that it does it for you. This is what that calculator looks like. This is the one you should have for your exam. All right. So you solve for B. It's 2 square root of 17. Now sometimes they're going to have this as an answer, or they may have it as a decimal. Of course, you should know it's easy to change it to a decimal. You just hit the little arrow key, and it changes it to 8.24. Okay. So you may see either or answer. All right. Now the other side of this triangle is 32, and that's on the original picture. So now I can do A the same way. I match A with 32. A over 32 is equal to 2 over A. Again, it looks like a geometric mean problem. You get A squared equals 64. So A is equal to the square root of 64, which is 8. And now I have the answer for A and B. All right, 47. 47 says find the length of the altitude. Now the nice part about this is exactly how a geometric mean problem is. So in other words, that type of picture, you can do the shortcut. You can just set up a geometric mean, which is 7 over x equals x over 21. So whenever you see a picture like 47, which involves, you have a right triangle, okay, and then you have an altitude coming from that right triangle, and you have this piece and this piece. That is what we call a geometric mean problem. You don't have to separate it into 3 triangles. You can, you'll still get the same answer, or you can do the shortcut and know that this is the geometric mean. So you can always go 7 over x equals x over 21 every single time. You could have done that for 46 as well. Okay. But 46, you would have only found one of the two measurements. The other measurement, you're going to have to write a proportion. And if you don't know what sides match, you're going to end up with a wrong answer. That's why I broke that one into 3 different triangles. Okay, problem 48. Hopefully you can cross multiply solve. You have the answers with the questions. Problem 48. This is the side splitter theorem. Why? Because those lines are parallel. Because they're parallel, you can just extend them and pretend they're fraction bars. Okay, so here we come up with a true algebra type question, and I guarantee you they will have one of these on your exam. So you have x over x plus 5 equals x minus 2 over x plus 1. Now this is a question that mostly the honors kids have done simply because it involves foiling. But if you've passed algebra, you should be able to do this as well. So it would be x times x plus 1 because we're cross multiplying. So that's x squared plus x equals. And when I cross multiply this way, I get x squared. Hopefully you know you get 5x and minus 2x, which would be 3x. And then negative 2 times 5 is minus 10. Now, I did that in my head. I can tell you that you probably will need to do FOIL, which would be this, and you go this one x squared, this one 5x, this one negative 2x, this one negative 10. Okay? So making sure you understand what you will need to do is kind of important. All right. And then you solve this equation. So I got to get all my x's to one side. So when I move this over here, it becomes negative x squared, and these cancel out. I move 3x over here, it becomes negative 3x, and I get negative 3x and x is negative 2x equals negative 10. Hopefully then you know you divide by negative 2, you get x equals 5. And then I go back and I make sure I reread the question, and it says, what is the value of x? I found the answer. Again, on the test, you have to be careful because a lot of times they're bimodular, meaning you do one problem to solve for another. So if they said, what was the length of the shortest side? So I'd have to look at all my answers and find the shortest answer. Hopefully you know it would be x minus 2, which would be 3. So the shortest piece of a side there would be 3. All right, problem 49. Problem 49 asks for the value of x again. Okay, so that means I'm solving. It also involves the side splitter theorem one more time. Why? Because I have parallel lines. So I do 3x over 4x equals 3x plus 7 over 5x minus 8. Now, some of you might be smart enough to look at this and go, hey, wait a minute. I remember doing fractions in Algebra 1, and I know that I could take an x out of this. I can reduce that. So go ahead and reduce it. You're allowed to. The x's cancel out. So now you're just left with 3 over 4 is equal to 3x plus 7 over 5x minus 8. Now you don't have anything squared anymore. So when I cross multiply, we get 15x minus 24 distributing equals 12x plus 28, correct? Now I do my algebra. So I take 12x and bring it over here, and it becomes negative 12x, which gives me 3x. Take negative 24, and it becomes positive 24. So I get 3x equals, correct, 52. Divide both sides by 3. I get does it go in evenly? No, it does not. Okay, so you just leave it 52 over 3. Remember, if you divide a number and it doesn't go in evenly, rather than writing it as a continuous decimal, you just leave it as the fraction, 52 over 3. Now, some of you sit there, oh, well, I'm not sure if that reduces. That's when you use your calculator and go 52 over 3 and hit enter, and it is reduced, 52 over 3. Okay, problem 50. 50 says, hey, it's bisected. LO is the bisector. What's wrong with the picture? There's no congruency marks. This is LO right here. So you should know that you're supposed to add congruency marks, which means whatever is over here is equal to whatever over here, and whatever is here is equal to whatever is here. They're the same. We've done this a bunch of times. Okay, so they said LM is 18, which is down here. And it says NO is 4. Uh-oh, look at that. And LN is 10. They want to know what this is. Well, we just stated that when an angle is a bisector and it's bisected, we know that not only are those two angles equal, but the distance from here to the side and here to the side is also equal. Good job. So this answer is 4. All right, problem 51. Name the plane that is represented by the top of the box. Hopefully you know the top has what's on top. So that would be plane. You have to use the word plane to name a plane. You just can't say a whole bunch of letters. It's plane A, B, J, C, D, I. You can use all 6 of them, or you can use 3 of them. You got to use at least 3, but you can do all 6. So that would be A, B, J, C, D, I. And notice you have to go one direction or the other. One direction. So if you wanted to, you could actually read this backwards and it would be the same, as long as they're going in order. So you start at any spot and then go around and list the points. Do you have to list all of them? No. How many do you have to list? At least 3. That's the rule for naming a plane. You have to use at least 3. And they can't be on the same line. So plane BJC would be incorrect because B, J, and C are all on the same line. So you have to use 3 points that are not on the same line. 52. Name a line. Hopefully you know that would be line RS. What would be the other way of naming that line? You could call it line RS. Either one of them would work. You can't call it line R, you can't call it line S. Those are capital letters. The only time you can call it by one letter is if there's a little lowercase letter by the arrow, like M. Then you can call it line M. But that's the difference between things that do have points and things that don't have points. All right, 53 is one that's visual, as well as if you just read the problem, you can hear what the answer is. It says, what is the intersection of plane STXW and the plane TUYX? Yes, you're looking for letters that repeat. So you see that the T and the X repeat. Guess where they intersect? T and X. Because they use the same letters twice. Line segment TX. And again, you have these answers. There's no reason for you to just write down the answers. They're, when you print out the papers, they're at the very back. Name opposite rays. So this revolves around, do you know what opposite rays are? Opposite rays. They give you the first ray is CA. Which of those 2 letters are important? First one or the second one? Correct. The first one is the one that's important because your opposite ray also has to start with the first letter. So if this is CA, the opposite ray also has to start with C. And you could pick, well, there's only one opposite ray, which would be CD. Again, based on the picture. Problem 55. Says which plane is parallel to ACGE? So I see ACGE. Parallel means it does not touch, which means none of the letters can be the same. Correct. So the only one that is parallel to it would be the only 4 other letters there. B, D, H, F. Okay, so the idea is making sure that you're looking at the letters. Can't repeat. Why? Because then they'd be on the same plane. Okay. When you're looking for an intersection, you're looking for repeating letters. When you're looking for something that does not intersect, you're looking for non-repeating letters. 56. We get into stuff we did at the beginning of the year. EF, FG, and EG. They said that the whole thing adds up to 20. So that means we're adding 2 things together to equal 20. This would be 3x minus 10 is one section. The other section was 4x minus 12, right? If I'm drawing that on the picture. But it says that the distance from here to here is 20. And again, we get to the possibility where one thing is next to the other. That means you add them. So this becomes 7x minus 22 equals 20. And then you use your mad algebra skills to solve. 57. 57, it says T is a midpoint, which means now we're talking about something that is cut into 2 equal pieces. Hey, midpoint, 2 equal pieces, which means I could put an equal sign where the midpoint is. And this side had a 6x, and this side has 4x plus 32. Guess what? The problem is already set up for you. Hey, look at that. You put an equal sign in between them, I'm ready to go. Yes, because that's what the midpoint means, is that you cut it into 2 equal pieces. So they are equal to each other. Again, you then use your algebra skills and solve. 58. Excuse me. It says BOC is 27. So that means here they give you a measurement. You would redraw it. BOC is 27 degrees, which is right here. So I put it on my picture. AOC is 47. Well, this is BOC. And then they tell me AOC, which is the whole thing, is 47. So now they're looking for AOB. So they give me the whole thing. This is one piece of it. I wonder what the other piece is. Hopefully you do some basic subtraction and you know the 2 pieces added together equal 47. So when you subtract one piece, you get the other. 59. Oh, 59. You should recognize that you have linear pairs and vertical angles, which means if you wanted to before you begin, you can do this. Okay, you know those 2 angles are equal, and those 2 angles are equal, and you know these 2 angles add up to 180. Why? Because they're a linear pair. Okay, and it says DEF is 114, so I put 114 here, and now I have all the measurements for this whole picture. I can put them in there. So if that's 114, I know that this adds up to 180, so this has to be 66, 66. Now I have all my measurements. Now I go back and I read the question again. It says, what are the measures of FEG? That's here, FEG. Okay, the 3 letters are, they make the angle. So a lot of times if you connect FEG, you'll see the angle. Oh, there it is. And HEG. HEG is HEG. Well, you already have the answers, 66 and 114. Yeah. Problem 60. MO bisects LMN. Okay, and again, they've given you directions and words on the problem, but the picture doesn't have any of the congruency marks, so they're expecting you to add them. So that means this piece and this piece are equal to each other. And then they say LMO, so LMO is 8x minus 23. And this is the part most of you, I've been talking to you about, and I tell you you should redraw it and put it on the picture, because you can see on your review, none of this stuff is on the picture. They're expecting you to put it on the picture, and then it makes sense. NMO is on the other side, which would be 2x plus 37. Well, what would you do with these two things? You put them equal to each other because the congruency marks tell you they're equal to each other. And then you use your algebra to solve. Now, the problem with this one is I believe after you solve for x, you need to go back and read what the question says, because it says solve for x and the measure of LMN. Now, LMN is the big angle. So it's not just this piece, it's not just this piece, it's both of them. So when I plug it back in to one of these two problems, I have to multiply it by 2 so I can get the whole answer. This is, again, where people have an issue, is because they answer one part of the question and then don't go back and read the other one. It's the final question wants the measurement of the whole thing, L, M, and N, which means you have to add those two angles together after you find them. Of course, you don't have to really add them together. You can multiply by 2 because both these angles are going to be the same. Correct. All right, 61. 61 states, identify the hypothesis and the conclusion. Hopefully everybody understands the hypothesis comes after the word. Yes, you are correct. It comes after the word if. And the conclusion comes after the word. Yay, look at that. I finally got my class to speak. And the conclusion comes after the word then. Okay, so it says if today is Wednesday, that would be the hypothesis, then tomorrow is Thursday. That would be the conclusion. A counterexample, is there a counterexample to that? No, there would not be. That's what makes the statement true. 62 says write an if-then statement. It says all triangles have 3 sides. So if and then. So hopefully you know the subjects are triangles and 3 sides. So if you are a triangle, then you have 3 sides. Whee! Good job. And many of you are going to find this easy because this was stuff from the beginning of the year. And because we've done if-then statements for the entire book, you've gotten used to knowing, oh, well, if means the first part, then is the second. So the converse, it says, if a number is divisible by 6, then it's divisible by 2. Well, is the converse would be, if it's divisible by 2, then it's divisible by 6. Right. All you do is you switch what was after then and what was after if, and make sure the sentences make sense. Remember, the verbs might change because of where you are in the sentence, or you might have to move a couple of the words around a little differently, because it won't sound correct. All right, so we'll continue with problem 63. 63 asks, what is the converse of the following conditional? And it says, if a number is divisible by 6, then it is divisible by 2. And converse means you take your if and your then, and you switch them. So hopefully you understand that it would be, if it is divisible by 2, then it is divisible by 6. All right, 64. Another if-then statement where it asks you to be biconditional. Hopefully you know that biconditional. The word biconditional means that both your if-then and your converse have to be true. So that means your if, then, and converse must both be true. If they're both true, then you can write it biconditional. If they're not both true, then they usually want you to give a counterexample, which means one of them can be proven false. All right, and remember we're talking about the hypothesis part. So if an angle is a right angle, then the measure is 90 degrees. Okay, and if the measure is 90 degrees, then the angle is a right angle. Those are both true. Okay, so you can write a biconditional. That means you write if and only if. Right? So that means you take off the if, you take off the then, and it would be if and only if. So it would be, it is a right triangle, excuse me, it is a right angle if and only if the measure is 90 degrees. So there's no if, there's no then, both of them are gone. You replace it with if and only if, and that goes in between the two sentences. All right, and that is 64. Sorry about that. 63 was your converse, knowing what the converse is. All right, 65. 65 is a proof. Okay, and you have to know your properties. You've learned about these in algebra. These are the properties of equality. So, for example, the first statement in any proof is always given. The second statement is what is happening. So they took out the x and plugged in a 7, which would be called substitution. Okay. All right, and then the next step was the subtraction property of equality, because they subtract 56 from both sides. So that's subtraction. The next step is the division property of equality. Because you divided both sides by 3, or excuse me, by 5. And then the last part was the reflexive property. Or excuse me, I'm sorry, the symmetric property. Okay, and it's symmetric because what was on one side of the equation is equal to something on the other side, and then the next step flipped them. So. All right, 66. 66 is another proof, and you have to find the missing part. Hopefully you understand that there's the additive property of equality. That's where two angles are next to each other. You add them together, you get the bigger angle. So they show you that 1 plus 2 equals AFC. 3 plus 2 equals DFB. Okay. So they're showing you what angles are equal. That would be the additive property of equality. 67, naming a property. It starts with, and if you ever have a question about this, if you want to rewrite them, you rewrite them and just line up the equal signs, and you can see what's happening. So you have LM and PQ, PQ, and LM. So what did they do from here to here? They just switch sides, which is the symmetric property. Okay. When you do 68 again, if you have a question of what's happening, you take what's given to you and you go ahead and line up the congruencies and or equal sign, and you can easily see what's happening. So we have W is to X, and then X is to Y, and then they're going to compare W and Y. So a first thing is equal to a second thing, and then they repeated that second thing. When you have this repetition in this statement, it's the transitive property. When that repetition does not happen, it's substitution. So understanding that transitive property is where you have a pattern. Notice there's 3 statements. Transitive and the transitive property and the substitution property both have 3 statements. No, symmetric only has 2. All right, so we go on to 69. 69 asks, name an angle that's supplementary to EOD. That means we're looking for a linear pair. Okay, supplementary. And in that picture, that means it has to be next to it. So you have EOD, hopefully you know it's COD. You have EOD, the other one would be AOE. Okay, you're looking for 2 of them that would make a line. So here's your original angle that they're talking about. So you can make a line by drawing it this way, or make a line by drawing it this way. That's why it's one of those 2 angles. Because you're trying to make a linear pair. So it has to be connected to this one. 69. So this 68. 67. All right. Problem 70. 70 is talking about supplementary angles, or 2 angles that have the measure that add up to, should be 180. And complementary angles are 2 angles whose measurements add up to 90. These are definitions that you've had for over the last several years. These are things that you should know by now. They are the basics for geometry. So you've got supplementary, complementary, then of course linear pair. So these things are used over and over again. Hopefully you understand why that vocab is that important. 71 asks for what is the complement. Hopefully you know, you see the word complementary. Complement means the other angle. So if one angle is 36, its complement isn't that, oh, that's a very nice angle. The complement would be what other measurement adds up to 90, and that would be 54. So you're looking for 36 plus x equals 90. Okay, 72. 72 says 1 and 2 are supplementary angles, which means they add up to 180. And so that means they give you the measurements for angle 1 as x minus 11, and angle 2 is x plus 93 equals 180. And then this is where you do your algebra. So you add like terms, you end up with 2x plus 82 equals 180. And then you would subtract 82 from both sides, and then you would divide by 2. Now you have to be careful because the answer for x is not the answer for the problem. Again, once you get x as an answer, you read the problem again, and it says find the measure of each, which means you're supposed to plug it back in. I'm sorry, you had a question? Oh. All right, 73. They're talking about, if you look at that picture, you should know those angles are what? Correct, they're vertical angles. Okay. Vertical angles are what? Hopefully you know vertical angles are equal to each other. So you have 6x minus 7 equal to 5x plus 10. Okay, and again, you would turn around and find the answer for x. Make sure you reread the question, and the question just says find x. It doesn't ask you to plug it back in. But you always want to double check, because most of the time on any type of standardized test, they're going to have the answer for x as one of the multiple choice, and then they're going to turn around and ask you to plug it back in, and that answer will be there too. So you got to be really careful about what they're asking, because the math starts to look the same over and over again. 74. 74 states that you have a pair of parallel lines, and again, once you have the parallel lines and the transversal, you can go ahead and add all the congruency marks, because every pair of parallel lines and the transversal look the same. So you can go like this. There we go, there we go, there we go. And then the bottom looks the same as the top. So here we go, here we go, there we go, there we go. Finding the measurements will be easy. remembering what those angles are called, that's going to be the part you have to study for. So when you look at these, you know that they give you the measurement of 135. Now, granted, my picture doesn't look like their picture, but it's same concept. As long as you understand that, okay, that's 135, this is 135, and this is 135, and this is 135. And you know that the two angles next to each other are a linear pair, correct? So this would be, correct, 45, 45, 45, and 45. Now in the actual picture, the line's going the other direction, but as long as you understand that the angles are where they are. So this would be angle 1, this would be angle 3, 7, 2, 6, 4, and 5. And they ask for what is the measure of angle 5. Well, you have it right there. But you can do that same thing for every parallel lines and a transversal. The problem is not going to be the number. The problem is going to be when they ask what kind of angles are those. Hopefully you know 1 and 5 are alternate exterior angles. All right, 75. '75 again is another pair of parallel lines and a transversal. Is a pair of parallel lines and a transversal. They have the measure of angle 1 and the measure of angle 5, so you have to know how they're related. So you can actually go ahead and do the same thing and draw your parallel lines in a transversal and put the numbers, you know, add the congruency marks here, like we just did in the last picture. Okay, and angle 1 is 2x plus 44, and you can see that when you put the congruency marks there, that tells me that the two angles that they want me to do or have the same congruency mark, which means they're equal to each other. If they didn't have the same congruency mark, they add up to 180. So this one I can put 2x plus 44 equal to 5x plus 38. Put those two things equal to each other because in my picture, the congruency marks that I have added are equal to each other. So if you could take a pair of lines that cross and put congruency marks on like you're supposed to, when you have parallel lines, you just take those same marks and slide them down and put them on there again. And then if they give you measurements, all you have to do is match up the measurements that are equal or the measurements that add up to 180. All right, 76. 76 looks different because they have parallel lines and they have a triangle. And they have two transversals. So you have to be careful because they have two transversals. So when you draw this one, then there's a triangle in there too. Okay, so you separate them. The triangle has a measurement of 67 here. It also has the measurement of y minus 8. Okay. So that means we're missing a third angle. But in actuality, we're not. Because when you have these parallel lines and this transversal, this and this are the same. They're also interior angles. And in that triangle, this congruency mark is this one. They are the same. So they give you a measurement of 51 degrees. So that means you can put up here 51 degrees. Now you have all three angles. What do you know they do? They add up to equal 180. Okay. So you add them all up to equal 180, and you solve for y. Then once you get an answer for y, once you get an answer for y, you'll have to plug it back in, and you know that y minus 8 plus 51 degrees plus x minus 3, or excuse me, x minus 1, is also equal to 180 because they form on a line. All right, so we look at problem number 77. Again, 77 looks confusing, but you have to separate it. Hopefully you see that you have two transversals and then you also have a triangle in it. Okay. All right, so usually everything's going to be revolving around the triangle. So when I take the triangle out, hopefully you see that 38 degrees is vertical to this one. Okay, so that's 38 degrees. And you'll see that 74 is alternate interior to this one. So that means the only thing you're missing is this one. So in a triangle, what happens? Correct. 74 plus 38 plus x equals 180. Okay, and when you find that measurement, they ask for the measurement of angle Q. Hopefully you know that angle Q and this angle are vertical angles. All right. So many times they're going to ask you to have an answer for something that's not in the shape you need to do it in. They're expecting you to see the triangle and go, oh, a triangle has to add up to 180. Those measurements somehow get inside the triangle. Okay, 78. 78, they give you a picture, but this one's a little goofy because they give you the parallel lines and then they give you this picture. Okay, so this one's 25 degrees and this is 50 degrees, and they want to know what this angle measurement is. Now this is one you probably will not see on the exam. It requires a little bit of higher level thinking, but if you wanted to guess, 9 times out of 10 you're going to want to add something up to 90 degrees or add it up to 180. But in theory what they're trying to get you to do is complete the shape. So if this is 25 degrees, this over here would be how much? Correct. It would be 155 degrees, right? Because these two angles make a linear pair. This would be 180 minus x, and this is x. We've talked about this before. Okay, but these are a linear pair. All right. So then when you finish, you should end up with that measurement is also 25 degrees. Okay, because they're going to be equal to each other. You can actually take this and flip it to the other side if you wanted to. So it's like unhinging this and moving it, because the angle measurement is not going to change, just the position is. So when you unhinge that and move it, it will look like this. And the x would move over here. So if this is 25, that makes this 25 because it's alternate interior. And then if this is 155, that would make this 155. So they've basically taken it and broke it in half and flipped it. All right, problem 79. You should see you have 3 triangles in that one. And one of the triangles is 38, 79, and x. So that one should be easy to solve. And then once you solve for x, the other triangle has z on the other side of it. This is an interior and exterior. What do they add up to? They're a linear pair. They add up to 180, correct? Or up at the top, you have the big triangle, which has 38 and 19 next to each other. And when numbers are next to each other, you add them. So you would have this angle measurement, and you'd have 56. So you could find y. And then once you find y, you can find the smaller triangle. So being able to separate the triangles is basically what they want you to do, and see that you have a one-size triangle, you have the triangle off to the side, and then you have the entire picture. You can solve those in any order that you really wish to. There's a lot of different rules that you could use to solve those. It's just making sure you know the rules. You could use the exterior angle rule for this angle if you wanted to. You add these two together, they're going to equal this. If you don't remember all those, the simple rule of knowing triangles should suffice to be able to find the answer to how many degrees are in a triangle. Problem 80. 80 says classify a triangle whose angles measurements are 35, 87, and 58, which means all those angles are acute. So when they ask you to classify triangles, you have, if they give you angles, there's three ways you classify triangles with angles. They're either acute, obtuse, or right. So if they just give you angles, those are the angle names. If they give you sides, so everybody remember the sides names? They're scalene, which means none of them are equal, isosceles, and equilateral. Okay? So this one they ask for the angle measurement, so if all of them are acute, then it's acute. In an obtuse triangle, only one of them's obtuse. In a right triangle, one of them's right. So problem 81, find the value of x. Again, you can do this a whole bunch of different ways. You know that this angle and this angle are a linear pair, so if this is 134, you can find this measurement. They already give you 67, and then you can add 67, this measurement next, to equal 180. What they're looking for is the remote interior angles, 67 and x, add up to the exterior angle. So you can do 67 plus x equals 34. Either way, you will get the same answer. One just requires you to memorize more, the other one requires more math, or arithmetic, excuse me. All right, problem 82. 82 asks if BCDE is congruent to OPQR, which means you're matching letters. They said segment BC would be congruent to, most of you are pretty good at this, BC is congruent to OP because they match. All right.